Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of bomb calorimetry. Well, since it's difficult to measure heat, there are no instruments to really measure heat like a thermometer measures temperature or a scale measures weight. When trying to measure heat, what we have to do is use a bomb calorimeter and the concept of bomb calorimetry. And we can use the known specific heats or heat capacities of some sort of medium. In this case, the surroundings are going to be water. And you can dump in either a metal block or two liquids can get dumped in, and then you can figure out what the heat capacity is, or the final temperature should be, or initial temperature was, given pieces of a puzzle. So what is a calorimeter? Well, in this case, the most simple calorimeter is a styrofoam cup in which we know whatever fluid is in there, in this case water, is going to form the surroundings of your calorimeter. If you were to look up the specific heat of water on a table in your chemistry book, what you would get is 4.18 joules per gram degrees Celsius. Okay? Now what we can do is we can use that known specific heat of water, right? That's the amount of heat required to raise your sample by 1 degree Celsius if we're looking just at 1 gram per gram, right? So let's say you have an unknown metal solid and you know the temperature of this water in the cup is initially 25 degrees Celsius, and this would be the calorimeter or the surroundings. And you know that the metal block has a temperature of 65 degrees Celsius. You want to know what the heat capacity is of this metal so you can identify it, because you have a table with all the different metals and their heat capacities. So what you would do is you would use this concept here. You would use the fact that the Q of the system equals the negative Q of the surroundings, and depending on what's given, you're going to use Q equals C delta T or Q equals M sat. So in this case, the Q of the metal will equal the negative Q of the calorimeter, being the surroundings, the metal being the system. And they will both end up at the same temperature, final temperature. Let's say it was 42 degrees Celsius. And because I didn't give you a mass, you would have to use the C delta T equation. And you would say C delta T equals negative C delta T. One of them is going to be a C delta T for the calorimeter, which is going to be the water, using that 4.18 measure I gave you for the specific heat. And I would need to give you the mass of the water, so I don't know, 18 grams or 36 grams, it doesn't matter. And once I gave you the mass, you could plug in and it would look something like that. And actually the left side of this equation for that example I just gave you would have to be cat, because I didn't give you the mass of the metal. This M is not given, so it would just be C delta T. Remember, C equals MS. And then you know the mass of the calorimeter I gave you was 36. The specific heat was at 4.18. The delta T here would be, the initial temperature would be the water, which was at 25 degrees Celsius. And the final temperature is 65. So you would just plug in a 65 minus a 25 over here. And that would be degrees Celsius. And then here we would have specific heat, which was 4.18. And then the mass, which was 36 grams. And there's one side of your equation with a negative sign. Don't forget the negative sign. And then the left side would be the C that we're looking for. We don't know the C. And then the delta T, well, we know the initial temperature of the metal block. The initial temperature was 65 degrees Celsius, and the final temperature is 42, so we would have a 42 degrees Celsius. And then you just solve. Literally just addition, subtraction, division at that point. And no, yeah, and then 65 was the initial here. Okay. It should have been a 42 over here. Sorry about that. The final temperature for both will be the same usually. All right, so that's basically it. And then you can solve for C. If mass was given, then you could solve for S. So that's the basic crux of it. You might have a fancier calorimeter, but it's always going to be Q of system equals negative Q of surroundings. The surroundings will always be the calorimeter. The system will either be the reaction or the metal piece. That's basically it to bomb calorimetry. I hope I've eliminated enough doubts for you to practice the problems. Check out the example videos. Thank you and have a nice day.